Welcome to our lesson today, where we study cardinality of sets. By cardinality of sets, we mean the number of elements of that set. For instance, if set A has the elements A, B, and C, what is the cardinality of this set? In other words, how many elements does A contain? That's what we'll be looking at today. So by cardinality of sets, as I've already said, we mean the number of elements, and therefore this set has 3 elements. It's therefore of cardinality 3, or it has cardinality 3. So our notations will be using this n to mean the number of elements in set A. For instance, we can write for this set, you can write that the number of elements in set A are 3. We can also use this to mean cardinality of A, and so we can still write that the cardinality of A is 3. So these are the notation we'll be using. This means the number of elements in A, and again this one means the number of elements in A, set A. Now, so that I've already stated this. I've already said that if A has k elements, if set A has k elements, then we can write this, that set A has k elements, or the cardinality of A is k. For instance, set A here comprises of elements A, B, C, D, and therefore its cardinality is 4. That's what I've written here. So I've already stated that we'll be using this symbol to mean cardinality of A, and again we'll be using this one. They mean the same thing, cardinality of A. So what is a finite set? By definition, we say that this is a set of finite cardinality. It's a set with a finite number of elements. That's what we mean by finite sets. We can look at examples, and our first example is find the cardinality of the following sets. In other words, how many elements? So it's very easy. For this one, we can say this set A has 1, 2, 3, 4, 5 elements, and therefore the cardinality of A is 5. What about this one? This them set. The cardinality of this set is 0. It has no elements. Its cardinality is 0. What about this one? Set B has this element 1, 2, then this is 1 element. This is 1, 2, 3, 4, 5, 6, and then 7. So this one has 7 elements. So you should not count this one as 2 elements here. This is 1 element. And this is another 1 element. So 1, 2, 3, 4, 5, 6, 7. So the cardinality of set B is 7. So as I said, I can write it this way, or if you want, you can write it as cardinality of B is 7. So let it mean the same thing, cardinality of B. Okay, so what about this other one? So these sets that we're looking at, these are finite sets. They are finite number of elements. What about this one? It has elements. This set A has elements 1, 2, 3, dot, dot, dot. Dot means that we continue. The numbers continue from 3. The next one is 4, then 5, 6, up to 14, 15, then 16. So this set has 16 elements. So the cardinality of this set A is 16. So dot here, dot means continuation of that pattern. and the pattern continues. So it was 1, 2, 3, and therefore the pattern continues 4, 5, up to 15, and then 16. So the cardinality of this set is therefore 16. What is an infinite set? We say that these are set with an infinite cardinality. Infinite cardinality. So the number of elements there are infinite. Let's look at an example of sets with the infinite cardinality. This set A has elements 1, 2, 3. Then the pattern continues. We do not know the last element here. There are infinitely many elements. These are many elements. So the last element here is not stated. So this is a set of infinite cardinality. In fact, if we were to use a set builder notation, these are what you write it. You'll say that set A is a set comprising of elements X such that X is natural number. Is a natural number. So these are natural numbers. 1, 2, 3, and so on. So our question was, what is the cardinality of this set A? And we are saying that the cardinality of this set A is infinite. Is infinity. What about this one? The same thing. 1, 3, 5, dot, dot, dot. So the sequence continues. These were odd numbers. 1, 3, 5. So we expect the next one to be 7, and then 9, and so on. So again, if you were to write a set builder notation, we would say that these are sets comprising of elements X such that X is an odd number. X is an odd number. The set comprising of elements X which are odd numbers. Now the cardinality of this set, the cardinality of this set 1, 3, 5, the cardinality of this set is again infinity. It has infinite number of elements. The same to this, -3, -2, -1. So the sequence continues, and we are saying that the cardinality again of this set is infinity. So we've looked at examples of finite sets and examples of infinite sets, and we've known what cardinality means, number of elements in that set. Now, supposing you're given two sets, how do we find the number of elements of those two sets together, put together, or the number of elements in the union of two sets? So that's what I've written here. I've said that for any two sets A and B, then the number of elements in the union will be given by the number of elements in A plus the number of elements in B, then minus the number of elements in their intersection. So we subtract the number of elements in the intersection to avoid counting some elements several times. So that's why, to determine this number of elements in the union, we just took the number of elements in A, then added the number of elements in B, and then subtracted those in the intersection, so as to avoid counting some elements several times or twice. What about if there were three elements? No, if there were three sets. If there were three sets, how do we find the number of elements in the union? And we have said that for any three sets A, B, C, the number of elements in the union would be given by the number of elements in A plus those in B plus those in C, then minus those in the intersection of A and B, minus those in the intersection of A and C, minus those in the intersection of B and C, and then plus those in the intersection of A, B, and C. So remember again, why we are subtracting this is to avoid counting some elements twice. And we have to add those in the common intersection. We can generalize this even to 4 sets, 5 sets, and so on. This can be generalized. So let's look at examples. Let set A comprise of this, and then set B comprise of this, and then set C be with these elements. The question is, what are the number of elements in the union of A and B? So, in fact, you can get the union of A and B and then just count the elements. And we saw how to find the union, the number of elements in the union, how to find the union of 2 sets in our last video on subsets and operation on sets. In that video, we looked at how to find the union, the intersection, the complement, and the difference of 2 sets. Now, so we are asked to, I stated that we can find the union of these 2 sets, then just count the elements. But I want us to use the formula we've had above. So the number of elements in the union of A and B is given by the number of elements in A plus the number of elements in B, then minus the number of elements in the intersection to avoid counting other elements twice. Now, how many elements are in A? 1, 2, 3, 4, 5, 6. We have 6 elements in A. Let me do it from somewhere else so that we avoid confusing the questions. So we are getting the number of elements in A union B, and we've already stated the formula here. So just saying the number of elements in A are 1, 2, 3, 4, 5, 6. Number of elements in B are 1, 2, 3, 4, 5. And then those in the intersection. Let's see which ones are in the intersection. I can see that 5 and 7 are in both sets. 5 and 7 and even 9 they're in both sets. So they are in the intersection. So we have 3 elements in the intersection. And what does this give us? This is the 11 minus that, and that gives us 8 elements. So the union of A and B has 8 elements. What about the union of B and C? The union of B and C. And we know that this will be given by the number of elements in B plus the number of elements in C, then minus the number of elements in the intersection. Number of elements in the intersection. How many elements are in B? In B has 1, 2, 3, 4, 5 elements. What about C? C has 1, 2, 3, 4, 5, 6, 7. Let me see. 1, 2, 3, 4, 5, 6, 7 elements. What about the intersection? Let's see what the intersection has. So I can see that 5 is here, is also in this set. 9 is in this set, is also in this set. Is there another element in the intersection? 11, 12 is not here. 7 is not here. So this intersection has 2 elements. That means the union has 10. The union has 10. And then finally, this will be given by the number of elements in A plus the number of elements in B plus the number of elements in C minus the number of elements in the intersection of A and B minus the number of elements in the intersection of A and C minus the number of elements in the intersection of B and C, and then plus the number of elements in the intersection of A, B, and C. So how many elements are in A? A has 1, 2, 3, 4, 5, 6 elements. B has 1, 2, 3, 4, 5 elements. C has 1, 2, 3, 4, 5, 6, 7 elements. The intersection of A and B had 3. 1, 2, 3. Had 3. The intersection of A and C, let's find out. A and C, C has a 2 here, which is also in A. It has a 5, which is also in A. It has a 9, which is also in A. Is there any other? Because we are left with 3 and 1 and 7, which are not there. So the intersection of A and C has 1, 2, 3 elements. What about the intersection of B and C? We have found it to have 2 elements. What about the common intersection? A, B, C. How many elements? So let me see. Here's a mate. Let me erase this. So I can see there is a 7. No, 7 is not in all the sets. 9. 9 is in this set. It's also in this set, and then in this set. 1 is not common. 2 is not common. 3 is not common. 5 is common. So you have 5 in this set, then in this set. 7 is not common. So it only has 2. And therefore, this union has how many elements? These are 6, 12. These are 12 elements. And yes, I had done the same questions. I had already done them here. So that's how we do it. Let's look at this other question. It says that a sakwa R has 346 customers. In a certain year, 119 of the customers took car loan, 92 took mortgage loans, and while 108 customers took school fees loans. Of these customers who borrowed loans, 17 took both school fees and car loans, 27 took both school fees and mortgage loans, while 16 took both mortgage and car loans. 7 customers took all the 3 loans. Find the number of customers that took at least one of the loans. And then lastly, the other question is draw a Venn diagram to illustrate this information. And then how many customers took only car loan, only mortgage loan, and only school fees loans. Now, so we have mortgage, we have fees, and we have car loans. These are 3 sets. These are 3 sets. So we want those that took at least one of the loans. So that means we are looking for the number of elements in mortgage, union, fees, union, car. And this will be the same as those that took mortgage loans plus those that took fees plus those that took car loans minus those that took mortgage and fees, those minus those that took mortgage and car loans, minus those that took fees and car loans, plus those that took all the three, mortgage, fees, and car. So how many took mortgage? And the question says 92 took mortgage, 108 took fees, and car loans, they were 119. Those that took mortgage and fees, of these customers, 17 took fees and car, 27 took both fees and mortgage. Fees and mortgage, that's what we're looking at for. How many are those? 27. Mortgage and car, 17 took fees and car, 16 mortgage and car, 16 took mortgage and car loans, and then these others were 17. And those who took all the loans was 7. So this one can be done on our calculator to get 266 customers. 266 customers took at least one of the loans. So that means those who never took any loan, are 346 minus 266. Those ones never took any loan. So the other question is draw a Venn diagram to illustrate this information. Let's just do that. Let's draw a Venn diagram, and you know that when you are drawing a Venn diagram, you must have, let me begin by drawing the circles to represent the sets. I will do circle, just a minute. Yeah, circles represent the sets. I have this circle, I have this one, and then I have this one. And then you must have a rectangle to represent this. Just a minute. So we had the mortgage, we had the car, and the fees. Let's go back to the question and get the details. So when you're drawing this, remember the circles here represent the sets. So this one represents those that took mortgage, this one took those that took car loans, and this one that took fees loans. And the rectangle must be there to represent the universal set. Now, so it's easier for me to begin by placing the ones that took all the three loans. And were they 7? There were 7. Took all the three loans. So I'll begin by inserting those that took intersection, those that took loans Let me just erase this first of all so that I can enlarge it. Just want to enlarge this. So for me to enlarge it, I must first of all delete everything in it, anything that I've added. Otherwise, it will not enlarge. And I want it enlarged so that you can see it. It's okay. So let me now see if it can be enlarged. Still, it cannot. Okay. Okay, there's no problem. It's not enlarging. So, but we can see that with this for 6 customers, 119 took car loans, 92 took mortgage loans, 108 took school fees loans. Of these customers who borrowed, 17 took both school fees and car. 17 took both school fees and car. Let's go to where school fees and car is. This is school fees and car 17. So this is already 7. That means I only need a 10 here because already 7 is in the intersection. So this is 10. School fees and car. And then we have 27 took both fees and mortgage. 27 took both fees and mortgage. Fees and mortgage. 27. But we already have 7. So I only need a 20 here to make it 27. And then we have 16 took mortgage and car. 16 mortgage and car. Mortgage and car 16. So that means I need 9. I need 9 at that point. And then how many took 119 of the customers took car loans. Car loans 119. That means for me to get the number to put here, it should be 119 minus what is here? 119 minus 9 minus 7 minus 10, and I'm getting that to be 93. So this one took only car loans. And then we have 92 took mortgage loans. 92 took mortgage loans. So 92 minus this, minus this, minus this gives me those who took only mortgage loans, and I'm getting that to be 56. And then finally we have 108 took school fees. 108 took school fees. So I come to this position of school fees, 119. So 119 minus this, minus this, minus this gives me the number that took only fees, loans, and these are 71 customers. So if I total this, it should give me the same number, 266. And we had how many customers? We had 346. So 346 is in our calculator. 346 minus 266 gives me the number of customers who never took any loan, and I can put them here to be 80. 80 customers took no loan. So the question is, how many customers took only car loans? And we already have the answer that only car loans, they were 93. What about only mortgage? The number of customers who took only mortgage were 56. What about those who took only fees loan? And this one, he found this to be 71. 71 customers took only fees loans. And this is how we draw the Venn diagram. You know that I've included those that took only car, those that took and I began by putting those that took all the loans, and then came to those that were the intersection, those that were sharing, took two loans, those that took two loans. Then from there now came to those that took and one loan each. Yeah, that's about cardinality. So we looked at cardinality of sets. Now we looked at those are the number of elements in a set, and we come up to this point where we looked at the number of elements in the union of sets. So thank you for being with us in this video, and welcome for the next video where we'll be looking at other topics in set theory. Thank you.